working with a linear versus nonlinear function. So first of all, let's review. We need to describe how we can tell the difference between a linear versus a nonlinear function. Well, linear has the word line in it. So if we are looking at a graph of a linear function, it is going to show a constant rate of change, a straight line when we get to see the graph. Okay, it's constantly going to do the same thing the whole way throughout the graph. The slope is going to be the same, and then also the change between every interval is also going to be the same. A nonlinear function, on the other hand, does not have a constant rate of change. So when it's graphed, it does not create a perfectly straight line. It might create a curved line. So we might see something that looks like this, like we worked with yesterday. It may show us something even like this as we get older and start working with some more complex functions. It could also show us something that would look like a V. The V is actually going to be represented when we work with absolute value. That's something that you'll work on as a freshman or as in Algebra 1, I should say. So non-linear functions are going to be a non-straight line. Yes, it's still a line, but it's no longer straight. Okay, so determine linear and nonlinear from a table. So when determining whether a function is linear or nonlinear, we're going to go ahead and look at our x and our y values, and we're going to identify what's happening between those. Now, yes, we could go through and graph these and see what the picture actually looks like, but there is another method. If they were to just ask us a question based off of the points that would be on a graph, we should be able to determine whether it's going to create a linear versus a nonlinear by looking at the rate of change. So we're going to go ahead and look at our x's here and see what's happening to get from the first x to the next, and we'll continue the pattern to make sure that the pattern's the same. So here we go from 3 to 6, so that would be either taking it times 2 or adding 6. So we're just, or not adding 6, adding 3, sorry. We're just going to go ahead and kind of take a peek at these. Okay, and see which pattern continues if it does. So when we look at the next one from 3 to 6, or from 6 to 9, we're adding 3. So it looks like we're doing an add of 3 every single time. So the next one, does it still meet that sequence? Yes, it does. 9 plus 3 does give us 12. So it looks like we're adding 3. Now, in order for this to be linear, we also have to have the same pattern happening within the y's. Not necessarily the same plus 3, but we have to have a pattern that's consistently the same between each y. So here, when I go through and I check this, from 4 to 32, we would go minus 8. From 32 to 24, that again is minus 8. And from 24 to 16, we have minus 8. So when I'm looking at this table without having to graph this, if I see that the pattern is the same between all of my x's and all of my y's, then this is considered a linear function. Okay. So letter B, let's go ahead and check once again to see if we have the same pattern happening between all of our x's, and then also a constant pattern happening between our y's. So let's see, from 1 to 3, we would be adding 2. From 3 to 5, adding 2. And from 5 to 7, we would be adding 2. So there we've got a constant pattern. But once again, in order for this to be showing a linear function or a linear pattern, we must also have a pattern that is happening between our y's. So let's see, the first set we've got from 2 to 11, it looks like we're adding 9. From 11 to 33, we're adding 22. From 33 to 88, it looks like we're adding what, 55. So we do not have the same pattern happening in our y's. So this would now be a non-linear pattern. Okay, yes, we have the same pattern up in our x's, but remember, you must have a pattern that is constant also between your y's. They do not have to follow the same pattern between x and y, but you must have that same constant function happening to each of those y's or each of those x's. Mainly the y's, because you can change your x's. Okay. You will notice, though, as you get older, sometimes they skip values of x's. So if you were to check in a table to see if there is a pattern, make sure that the pattern in the x's is a constant pattern. Okay, because I could go through and like on this first one, maybe instead of skipping just 3, maybe I skipped 6. So maybe this would be 18. You would see a constant pattern also within the y's. It's just that there was a bigger gap here than 3. Sometimes that happens. Sometimes you have to see the graph unless you're really good with numbers and you can decipher that. But remember, you have to have a constant pattern between both your x's and your y's. Okay, so let's go ahead and try another one. So this is just where a table is set up slightly different. Instead of it being a horizontal table, it's a vertical table. So we're comparing our x's. So these are all of my x's here. I need to check the pattern on that. So it looks like we're adding 7, adding 7, adding 7. So we have a constant pattern in the x's. So now we'll check to see with the y's if it's constant. -5, -5, -5. So is this linear? Was it constant on both sides? Yes, so that would be a linear function. Okay, constant pattern is linear. Okay, so I want you guys to try these two. So remember yesterday that number 3, we don't have a picture. Okay, but yesterday you guys graphed some pictures and you looked at linear versus nonlinear. So I want you to go ahead, pause your video, work your way through numbers 2 and 3, and determine whether these are showing a linear or a nonlinear function. Okay, this one was showing linear. Okay, each of these was going down by 4, and each of my x's was increasing by 2. And number 3, well, this was nonlinear. Okay, this was actually showing us the picture. Yes, I could pull information off of there and do data points, but I don't have to. We can visually see that this is not a perfectly straight line. Yes, there are 2 straight lines, but this is considered one function. When I've got both of those pieces together, they create the one line. This would be a line that's it's folded, it's showing us a V, so this would be considered nonlinear.